Right, solving trig equations. We looked at it, of course, back in term 1, but now we have more trig identities and things we can use to help us solve these equations. So let's have a look at some. And this is one that was typical last time, you know, cos 2 theta equals a half. And we said, oh, hang on, if we're looking for theta in between 0 and 360, then I'll look for 2 theta between 0 and 720. And so we'll find our acute angle. We know we're in quadrants 1 and quadrants 4. The acute angle turns out to be 60 degrees. So I know that 2 theta in the first quadrant, it'll be the alpha or the 60 degrees. In the second quadrant, it'll be 360 minus that. But of course, we're going around twice. And so we end up with 60, 300, 420, 660. That's what 2 theta equals. So divide everything by 2 and we get our answers. We've now got another way we could solve that, because we now have formulas that we can change cos 2 theta into just a trig expression with theta in it, rather than 2 theta. So another way we could do it, I mean, you might still want to do it the first way. It's fine, it works out, it gets the answer. But I could now go, oh, cos 2 theta equals a half. Tell you what, I'm going to change cos 2 theta. Now, there's 3 I could change it to, but I've just chosen the 2 cos squared theta minus 1. Rearranging that, I get cos squared is 3/4. So cos theta will be plus or minus the square root of 3 on 2. So it's both positive and negative. So in fact, I'm in all 4 quadrants. Oh, look at that, the full butterfly. Whee-hee. The acute angle is 30 degrees, but I'm in all 4 quadrants, and we end up, of course, with the same 4 angles. So we have alternative ways we could go and solve them. As I say, the first way is still fine. It's just a matter of preference how you want to approach the problem. 4 sec squared is 3 tan x plus 5. We saw ones like this before too, where we said, oh, hang on, I've got a sec squared, but I've got a tan as well. I could rewrite the sec squared and change that to 1 plus tan squared, so it becomes 4 plus 4 tan squared, and we create a quadratic equation, which if we're lucky factorises, phew. If we're unlucky, we'd have to use a quadratic formula, of course. So I get tan x is minus 1/4, or tan x equals 1. So for my first one, quadrant 2 or quadrant 4, the acute angle, 14 degrees 2, and then that gives me 2 answers for that part of the solution. But I've got another part of the solution, tan x equals 1. That's one of our exact values, actually. Tan of 45 is 1, isn't it? So x would be, in the first quadrant, it'll be 45. But in the third quadrant would have 225. So combining both sets of solutions together, I like to put them in order because it just looks nicer. But now we could get questions like this. Cos 2 theta is 4 cos squared theta minus 2 sine squared thetas. So I've got trig ratios that have been squared. I've got double angles, how to approach it. Ideas. I could change my cos 2 theta. What to change it into? Because I've got cos squareds and sine squareds on the other side. I could go cos squared minus sine squared. I could go 2 cos squared minus 1. I could go 1 minus... Oh, hang on. I wonder if I did. I can't remember how I actually did it in the notes, but I just realised something. If I go 1 minus 2 sine squared, see how there's minus 2 sine squared on the right-hand side as well? Which will then cancel, leaving me with just coses. I wonder if it was a... Did I? No, I wasn't that clever. Okay. Gee, that would have been a good way to do it, though. Damn, I wish I'd noticed that. All right, so I went cos squared minus sine squared. And so I've then said 3 cos squared equals sine squared. Oh, I see where I'm heading. I'm going to create a tan squared. So I'm going to divide both sides by the cos squared. And I get tan squared is 3. Tan is plus or minus root 3. So I'm in 4 quadrants again. The acute angle, 60 degrees is the acute angle, but I'm in all 4 quadrants. So there's my 4 answers. I wonder if it would have been quicker had I gone the other way. Anyway, doesn't matter. It would have got the same answers. There's no problems there. But say, in hindsight, it would have been a far more clever way of doing it, wouldn't it? I would have gone 1 minus 2 sine squared, and the minus 2 sine squareds would have cancelled. And then I would have said, 4 cos squared's 1, cos squared's a quarter, so cos is plus or minus a half. And that's the same exact value, and yeah, that would have been clever that way. Anyway, let us move on. Here's one from 2000 paper. Cos 2 theta equals sine theta. Gee, they like these cos 2 thetas, don't they? Possibly it's because we have to make a decision which one to use. Again, I could go cos squared minus sine squared, 2 cos squared minus 1 minus 2 sine squared. I think in this case it would be logical to go the 1 minus 2 sine squared, so I've only got sines in it. Did I? Yes, I did. So I'm going to create a quadratic equation involving the sines, and yes, it factorizes. Thank you to the examiners who set this question, making my life a little bit easier. So we get sine theta is a half, or sine theta is negative 1. So quadrant 1 or quadrant 2, find the acute angle. Before I found the acute angle, sine theta equals negative 1 is a boundary value. So there's only one solution to that one, just 270 degrees. And we get alpha is 30, 30 and 150. Combining all three solutions together, we get 30, 150 and 270 for the boundary value of negative 1. Wow, now I really have gone back in the years to find a question. 1992. Perhaps I was trying to find one without cos 2 theta on it. Sine 2 theta, something different. Well, in this case, I don't have a choice. There is only one relationship for sine 2 theta. That's 2 sine theta, cos theta. So let's sub that in. Temptation, don't do it, whatever you do. Temptation is to divide both sides by sine theta. Don't do it. Because it's possible sine theta could equal 0. And it's like dividing by 0. It's just like algebra. You don't divide by the x. You move to one side and factorise. So we do exactly the same thing. We could divide by the 2. That'll be all right, because the 2 can never equal 0. So that's fine. So we get 2 sine squared minus 2 sine theta cos theta. Factorise. And then now we get those two possibilities. If you divided by the sine theta, you would have lost the possibility that sine theta could be 0. Our other possibility, sine theta equals cos theta. Again, a boundary value. The other classic mistake. Whenever 0 is a solution, 360 will be a solution as well, because we're going around the whole circle. But 0 and 360 is the same point on the circle. So often people forget one or the other of those, because we're just in so much of a mindset of there'll be two answers, there'll be two answers. So be careful with that one. If 0 comes up, we know 360 will be as well. Sine theta equals cos theta. Rewrite that, make that tan theta equals 1. Again, a boundary value. Whee. That's 45 degrees. So we get 45, 225. We end up with 5 answers for that particular question. Okay, so 2D, some trig equations to play around with.